So, what's up everyone? Welcome to the lecture 6 of our trigonometry lecture series. For today's topic, we're gonna be discussing all about the principles in algebra and how to use them or how to integrate them in trigonometry. As well as we're also going to solve some examples involving verification of our trigonometric identities or proving trigonometric equations. So without further ado, let's start with the lecture. Pangmalakasang intro, pasok! Okay, so to start with the lecture, we have the review on the fundamental trigonometric identities. So first, we have the reciprocal identities. So we already know the basic reciprocal identities. So if you have cosecant, if you take the inverse of that, that is the value of your sine. Conversely, if you take the reciprocal of sine, you get the cosecant. Okay. Also, we have our cosine and tangent, secant and cotangent. For the quotient identities naman, again, tangent theta is basically equal to the sine of theta all over the cosine of theta. And our cotangent is the reciprocal naman of our tangent. So if the tangent is sine over cosine, cotangent is basically cosine over sine. So our Pythagorean identities, we have the sine of theta squared plus the cosine of theta squared, which is equal to 1. So basically, we only need to memorize this equation right here. It's because that these two are derived from this first equation. Okay, so let's try to derive the second equation. If we try to divide the first equation by the cosine of theta squared, the whole equation by the cosine of theta squared, we get sine of theta squared over cosine of theta squared is basically equal to tangent of theta squared. And cosine of theta squared all over the cosine of theta squared is equal to 1. This reduces to 1. So that's why we have it here. And 1 over cosine of theta squared is basically secant squared. Okay? And if we try to divide naman the first equation by the sine of theta squared, okay, what is this value equal to? Sine of theta squared over sine of theta squared. This reduces to 1. That's why here. And cosine of theta squared all over the sine of theta squared is cotangent from here. That is cotangent of theta squared, and 1 over sine of theta squared from here, that is cosecant of theta squared. Okay, so again, you only need to memorize this one, and it's not that difficult to memorize this equation. So to use our trigonometric identity, so I guess we've already discussed this one. We've already answered this similar type of problem in the previous video. So if you're given the value of your secant being equal to negative 3/2 and your tangent is greater than 0, so what are the values greater than 0? Those are the positive integers, meaning the sign convention of your tangent should be positive. Okay? The sign of your tangent function should be positive because it says here that it's greater than 0. Okay, and the value of your secant u is equal to negative 3/2. So since your secant u is equal to, in our reciprocal identities, what's the value of our secant u? That is equal to what? Secant u is basically equal to 1 over your cosine of u. So doing cross multiplication or taking the value of your cosine u is equal to what? 1 over secant u. This is the same with our reciprocal identities. Okay, wherein our secant u is given. Our secant u is given being equal to negative 3/2. So cosine of u is equal to 1 over negative 3/2. Okay, simplifying this fraction, I have cosine of u being equal to negative 2/3. Diba? If you have a value of your denominator be a fraction, so if you try to write that properly, so your denominator will be will be reciprocated. So if this is 3 over 2, this will become 2/3. Okay, diba? That's how you do fraction niya denominator in your algebra. Okay, since we now have the value of our cosine being equal to this one, we are asked to find all of the 6 trigonometric functions. What are those? You have cosine, you have sine, tangent, secant, cosecant, cotangent. You now have the value of your secant and cosine. Apat na lang of the 6. So, since you now have the value of your cosine, it's easy to find the other identities. Remember this equation, cosine of u squared plus sine of u squared is equal to 1. Remember that one for our Pythagorean identity. So, gamit na gamit yan. And since we now have the value of our cosine of u, we just substitute that to this equation. That will become 2/3 squared plus sine of u squared, that is equal to 1. Okay, and simplifying this one, this will become 4 over 9 positive, because negative 2 times negative 2 is positive 4, and 3 times 3, that's 9. So this is basically 4 over 9, and if you try to transfer that to the other side of the equation, that becomes negative. That will become negative 4 over 9. So sine of u squared is equal to 1 minus 4 over 9, or 2/3 squared, negative 2/3 squared. That's basically the same. So our sine, okay, I'll just write it here. Our sine of u squared is equal to 1 minus 4 over 9. So how do you subtract fractions from your algebra? So this will become 9 minus 4, so 5 over 9. Okay, taking the square root of both sides, this one cancels out. You'll be left with sine of u being equal to plus or minus. Since you're taking the square root, so it's always plus or minus. Okay, so it's because nga if you have, okay, if you're asked to find the square root of 9, so its answer will be plus or minus 3. Because if you try to square 3, that is 9. Also, if you try to square negative 3, that is also equal to 9. So therefore, the square root of 9 should be equal to plus or minus 3. Duduhati mo root. You have 2 roots in there. Okay? So, similar for this one, sine of u is equal to plus or minus square root of 5 over, what is the square root of 9? 3. So, you now have the value of your sine of u. Okay? Sine of u is either plus or minus square root of 5 over 3. But, take note, it says here that your tangent should be, what? Greater than 0. Your tangent should be greater than 0. That should be positive. What value of our sine should we consider in order for our tangent to be positive? Take note, the value of our cosine is negative. For our tangent to become positive, we need another negative. Diba? Okay, because tangent of u is equal to sine of u over cosine of u. Since we have a negative cosine of u, that is 2/3, negative 2/3, we need the negative root of our sine. So this will become negative 5 over 3 over our cosine of u, negative 2 over 3. The negative sign cancels out. Okay, it's not the negative sign that cancels out, because theoretically this has a negative 1 value in there. Okay, may dapat niya negative 1 value. The negative 1 cancels out. Okay, so I'm just showing how it's not banging ka mo sumering inka-cancel lang negative sign. No, theoretically may that din negative 1. The negative 1 cancels out, not the sign. Okay, so this one cancels out. Also for this 3, so you'll be left with the square root of 5 over 2. So you now have the value of your tangent, your cosine, and your sine. If you take the reciprocal of both of all of these trigonometric identities, you'll get secant, cosecant, and cotangent. Okay, since we now have we already have the value of our secant, let's try to find the cosecant. So what is our cosecant of u? That is 1 over sine. Cosecant of u is equal to 1 over sine of u. Or baliktar la kung ano nimo sine. Take the reciprocal of your sine. Since your sine is equal to negative 5 over 3, your cosecant should be equal to negative 3 over square root of 5. Rationalizing this one, multiply that one by square root of 5 over square root of 5. This is basically equal to 1, so that's just the same. So you'll be left with 3 square root of 5 over 5. This is now the value of your cosecant. And lastly, so we have cosine, sine, tangent, secant, cosecant. For our cotangent of u is just equal to the reciprocal of this one. So that is 2 over 5. Multiply that one by square root of 5 over square root of 5. You have 2 square root of 5 over 5. You now have the value of your cotangent. Questions? Claro? So I've already discussed this. I mean, I've already answered similar problems in our previous lecture. So kaya medyo madagmit na ang discussion. So I expect you've already mastered this one because I gave you tons of assignments already relating to I mean similar to these problems. Okay, see, I just erase this one. Eto. So we're done with using the fundamental identities to find all of those trigonometric identities, so on and so forth. So for this next example, we'll be using ideas in our algebra to be applied in trigonometry. So for this one, we are asked to simplify. I-simplify ko nun eh. We are asked to simplify sine of x multiplied by cosine of x squared minus sine of x. So how do you simplify this one? It's basically the same with a times b squared minus a. How do you simplify this one? Yun. We can factor this one. Right? Diba? Similar with this one. A times b squared minus a. We can factor this one. We can take sine. Diba? We can take sine. And we'll be left with cosine of x squared. Minus what? 1. But take note, what is this value equal to? Ano yung sabi natin? Cosine of x squared plus sine of x squared, that is equal to 1. Right? But if you try to multiply negative both sides, this is basically the same. Pareho lang ito era. So, you'll be left with cosine of x squared minus sine of x squared, that is equal to negative 1. Right? If you try to transpose this one to the other side of the equation, this becomes positive, right? So I'm gonna transpose this one to the other side of the equation. So sine x squared, that is equal to, since this is negative, if you transpose that to the other side, it will become positive, cosine of x squared minus 1. So therefore, this value right here is basically equal to sine of x squared. Negative sine of x squared. Okay? Sine of x, therefore, multiplied by what? Negative sine of x squared is equal to what? Negative sine of x squared. Yan it's basically the same with this one. X squared multiplied by x. What do you get? Sine of x cubed. Any questions? Again, what I'm showing you is how you can use the ideas, what you've done in your algebra. What have you, anong ginawa nyo nung algebra in trigonometry. Okay? Any questions? Sorry na. Sige. Ito na. We are asked to factor each expression. So for this one, and this one. Okay. Sige, let's try this one. How can we factor this expression? Hint, this is basically similar with a squared minus 1. How can we factor that out? Do we have factors for a squared minus 1? What are the factors for a squared minus 1? It's basically the same with this one, yeah. A squared minus 1. What are the factors? A plus 1 and a minus 1. Okay? Because if you try to multiply these binomials, you'll get a squared minus a plus a and negative 1. A and negative a cancels out. You'll be left with a squared minus 1. So, these are your factors. Tama. We have a plus 1 and a minus 1. Okay? So, if you try to convert that one to the given expression, so, if our a is second theta, so, parang ganun lang yan. Second theta, plus 1 multiplied by second theta minus 1. Again, if you try to multiply this out, you'll get second theta squared, minus second theta plus second theta minus 1. Second theta and minus second theta cancels out. You'll be left with this one. So, therefore, the factors are these two. Question. Claro? Is it clear? Again, algebra. This is a prelude to proving identities. This is a prelude in proving identities. If you think you're weak with the factoring expression, you might as well review your algebra, because this is a prerequisite in order for you to prove identities. If you can't do simple factoring, mahirapan kayo sa proving identities. Okay? What makes this difficult is because there is no certain way of answering each question. You need to think. That's what makes it difficult. You're gonna be using your brain. For letter B naman, how do we factor this one out? This is basically the same with 4x squared plus x minus 3. How do we factor this out? Have you heard of factoring by long division? Have you heard of that one? Factoring by long division. Okay, bumati naman kamay ito, di ba? So, if you try to factor this one by long division, so, let's just name my tangent theta equal to x. So, this will become 4x squared plus x minus 3. So, factoring out by long division, I try to write it here. 4x squared plus x minus 3. Let's try about I guess x minus 1 or x plus 1. Okay, so if I do that, I can have here 4x. So it will become 4x squared. 4x times x, 4x squared. 4x times 1, that is 4x. Then you subtract those. This one cancels out. You'll be left with negative 3x minus 3. Then if we try to use 3 in here, 3 times x, that will become negative 3x, and 3 times negative 3 times 1, that will become negative 3. Then you subtract the subtrahend. So the sign convention reverses. So if that's negative, it will become positive, and you cancel those out. So therefore, the factors are x plus 1 and 4x minus 3. Since our x is equal to tangent of theta, you'll be left with 4 tangent of theta minus 3 multiplied by tangent of theta plus 1. Okay? Algebra. Okay? So, yun. That's how you do it. Again, algebra. So, that's how you factor this expression. And the next one, we're given this expression right here, cosecant x squared minus cotangent of x minus 3. How do we factor out this expression? Remember our Pythagorean identity, di ba? Sine of theta squared plus cosine of theta squared is equal to 1. So if you try to divide by sine, so you get by sine squared, so you get 1 plus cotangent theta squared 1 over sine, that is cosecant x squared. This is already the hint. If you know this equation and you know how to factor out similar to this one, you can answer this expression. Okay, so I'm giving you 3 minutes to answer the problem, and afterwards, after 3 minutes, I'll be asking questions. Okay, your 3 minutes starts now. Go. So what's your answer? Very good. Galing. So how did we solve this problem? Since we know the value of our cosecant x squared, we can just substitute that this one. We can just substitute this one. So that will become 1 plus cotangent of this shouldn't be theta. Okay, that should be x. Okay, this is x, so this should become x. So this will become cotangent of x squared minus cotangent of x minus 3. Okay, so simplifying this expression, so I have cotangent of x squared minus cotangent of x minus 3 and plus 1. So that will become negative 2. So similar with this problem, you can just say that the factors are the cotangent of x minus 2 and cotangent of x plus 1. So because if you try to multiply this binomial, you'll have cotangent of x squared minus 2 cotangent of x plus cotangent of x. You will be left with 1 cotangent and negative 2. So this is your factors. Any questions? Questions? Okay. Eto, another application. So, if you're given this expression, you can simplify pa this further. So, how are you going to do that? Remember the value of your cotangent. What's the value of your cotangent? Cotangent of t is equal to what? That is cosine of t over sine of t. Okay, so try to notice this one. If you're given cotangent of t, so your trigonometric identity should be in t. So cosine of t, sine of t. If it is in x, so your trigonometric function should be in cosine of x, sine of x. If it is in alpha, cosine of alpha, sine of alpha. If it is in gamma or beta, madepende kung ano nga variable ang gingamit. Okay, with regards to your trigonometric identity. Okay, so if this one use t, so you're gonna be using t. Okay, so sine of t plus cotangent which is actually equal to cosine of t over sine of t, cosine of t over sine of t multiplied by cosine of t. What is cosine of t times cosine of t? What is x times x? So sine of t plus cosine of t squared over sine of t. Now, how are we going to simplify for this one further? This is basically the same with x plus y squared over x. How are we going to simplify this one? How do we add fractions? Okay, so it is similar to this one in the sense that if you have a fraction tapos you're trying to add these two values, you can write this one in terms denominator, in terms of this denominator. And how are you going to do that one? So you can have x times x over x. X over x is just basically equal to 1, right? Plus y squared over x. This is algebra. I'm just reviewing your algebra. And simplifying, so x times x, that is x squared over x plus y squared over x. Okay, since they have both denominators, so that is x and x squared plus y squared. That's how you add a whole number in the fraction. So if you try to use that idea in the question or in the example, it will look similar to this one. Okay, so if this is sine, so this will become sine squared. Sine t squared plus cosine of t squared over sine of t. But what is sine of t squared plus cosine of t squared? What's that equal to? That is 1. That is equal to 1, right? So that is 1 over sine of t. But what is 1 over sine of t equal to? That is cosecant. Okay? So imagine from here to this single expression. Di ba? Meaning cosecant of t can be equal, conversely, cosecant of t can be equal to this expression right here. Amazing, di ba? Okay, sige. So, another 3 minutes. Try to answer this expression and I'll get back to you after 3 minutes. Okay? Similar idea latera. Okay, your time starts now. Go. Okay, sige. What's your answer? Cosecant theta. How about the others? Any other answer? Sige, so it's basically the same with this one. So you have your denominator being equal to 1 plus cosine of theta, okay, times sine of theta. So this will become sine theta squared plus cosine of theta plus cosine of theta squared. So this is equal to 1. So 1 plus cosine of theta over 1 plus cosine of theta times sine of theta. Okay. So basically you can just cancel this out. So you'll be left with 1 over sine of theta. And 1 over sine of theta is basically equal to cosecant of theta. Question? Ito. We are to rewrite down this expression so that it's not in fractional form. How are we going to do that? Rewrite 1 over 1 plus sine of x so that it's not in fractional form. How are we going to do that? How can we make the denominator a single trigonometric identity? What do we know? We know that cosine of x squared plus sine of x squared is equal to 1. Ano pa? An tangent. But this involves sine, so I guess we're gonna be using this one. How can we make the denominator into a single trigonometric identity? We need to multiply something. What is that something? Okay. You need to multiply something so that your end product, okay, will be related to this equation right here. We need to multiply something in order for our denominator, in order for us to use this equation for our denominator. The question is, what is that something? So we have 1 over 1 plus sine of x. What should we multiply? Remember a squared minus 1. What are the factors for this one? We have a plus 1 and what? A minus 1. Right? Hello? So if you have sine of x squared minus 1, what are the factors? You have sine of x plus 1 and sine of x minus 1. Okay. So what should we multiply? I'll try to write this one. Sine x 1 plus sine x is just basically the same with sine of x plus 1. Balikad lera. Pareho lettera. What should we multiply? In order for us to generate this form, what should we multiply? Sine of x minus 1. Okay? How about the numerator? Same lagi hapon kay dapat itimig mo multiply 1 la iti a value. Okay? Sine of x minus 1 over sine of x minus 1 is just basically equal to 1. Okay? So the numerator will become sine of x minus 1 because sine of x minus 1 times 1, it's just basically the same, over sine of x squared minus 1, and that is equal to what? If you try to substitute 1 to the other side of the equation, you'll have sine of x minus 1 is equal to what? Transpose this one to the other side of the equation. Negative cosine of x. Okay? So, therefore, this is equal to sine of x minus 1 over negative cosine of x. Squared, sorry. Squared. Negative cosine of x squared. This should be squared, sorry. And therefore, this is equal to, if I try to break up this fraction, so in here over this, sine of x over cosine of x squared minus 1 over cosine of x squared. So, parang ganito yan. Sine of x over negative cosine of x squared minus cosine of x squared. Minus and minus, so you'll have plus. You'll end up plus. That's how you break up binomial fractions into two. The first term, divided by the denominator. Tapos use whatever sign in here. It's either minus or plus. Then, say minus 1 over the denominator. That's how you break up binomial fractions. Simplifying further, so what is this value equal to? Sine of x over cosine of x squared. May dani mo, usa ka sine x. Ganhin, usa nga cosine of x times cosine of x. Negative. Okay. Inihiya, this is tangent. And times 1, what is 1 over cosine? What is 1 over cosine? Secant. So, we have negative tangent x times secant of x plus 1 over cosine. What is 1 over cosine? Secant lagi hapon. So, takay, naka-squared man na nimo cosine. So, that will become secant of x squared. Or, if I try to write the positive first, so this will be equal to secant of x squared minus the tangent of x secant of x. This is now your simplified form. It's not in the fractional form anymore. From this, in fractional form, to here. Not fractional form. Question? Question. Ito, trigonometric substitution. So, in trigonometry, this is parang hindi siya napapansin. But when you enroll in integral calculus, this becomes this becomes dakot gamit ini when you are in your integral calculus, because there's a technique in integration which uses trigonometric substitution, and in order for you to use that technique, you need to have a basic understanding on how to use trigonometric substitution. So in here, I'll be discussing you on how to use trigonometric substitution in order for you to get the other functions of theta. Okay, because you're given tangent, so you can find sine, cosine, so on and so forth. Okay, so for this, for the first example, you're given x is equal to 2 tangent of theta, where you're gonna use the substitution to write the square root of 4 plus x squared as a trigonometric function of theta. Okay, so it says here that we need to substitute x by 2 tangent of theta. Okay, so from x is equal to 2 tangent of theta. From this equation, what is the value of theta? From this equation, what is the value of theta? Tangent theta is equal to what? Divide both sides by 2. 2 cancels out. This will become x over 2. Nakuha? Nakuha. Okay. And it says here that we are gonna use x to, we're gonna use the value of 2 tangent theta as x. So if we try to write 4, the square root of 4 plus x squared, using x being equal to 2 tangent of theta, we have 4 plus 2 tangent of theta squared. No. The squared should be put in here. Okay, simplifying, I have 4 plus 2 squared, that is 4, tangent theta squared. Ganyan lang yan. Or if in your algebra, it's similar with this one, x y squared. So that will become x squared y squared. Parang ganun lang yung nangyari dito. In-square ko yung 2 at saka yung tangent theta. What's the square of 2? I mean, what is 2 squared? That is 4. What is the tangent of theta squared? The tangent of theta squared. Ganyan lang yan. That's what happens. And factoring out 4, I have square root of 4 times 1 plus tangent of theta squared. Eto. What is 1 plus tangent theta squared equal to? Okay, di ba 1 plus tangent of theta squared is equal to what? Secant, di ba? So therefore, this expression is equal to secant. So that is equal to 4 plus, 4 times secant theta squared. Okay? So what is the square root of this one? 4 times secant theta squared. That is equal to 2 secant of theta. Okay? Nakuha. It's just basically the same with a squared plus b squared. So, if you try to combine those, so magiging ab squared. And if you try to take the square root, it becomes ab na lang. Parang ganun lang yan in your algebra. Okay, since we already know that this lot is equal to 2 secant of theta, so 4 plus x squared is equal to 2 secant of theta. We can now find the value of secant theta. Secant theta is equal to what? 4 plus x all over 2. So to verify if the value of secant theta and tangent theta are correct, we write a right triangle, wherein the value of tangent is x over 2, opposite over adjacent, and secant, what is secant? 1 over cosine, the reverse of cosine. So what is the trigonometric identity for cosine? That is opposite, adjacent over hypotenuse. Takay reciprocal man niya, so hypotenuse over adjacent. So since the hypotenuse is 4 plus x, this should be x squared pala, sorry. Okay, 4 plus x, square root of 4 plus x squared over 2. Hypotenuse over adjacent, that is for secant. So to verify, use Pythagorean theorem. X squared plus 2 squared, you take the square root, dapat amot yung hypotenuse. Correct ba? Diba? X squared plus 2 squared is just basically x squared plus 4. Meaning, correct ang imo value. This is gamit ini. Okay? Gamit ini hiya hayo integral calculus because you can convert this one. You can find other functions pa in here. So you can have the value of your cosine, your sine, your tangent, your secant, cosecant, and so on and so forth. Okay, from this one, tapos mag-integrate, madagmit. It's easier. Kay there are times na there are functions in your integral calculus that can't easily be integrated. That's why you use trigonometric substitution or integration by substitution for that matter. Okay, and in here, what I'm showing you is just how to use the trigonometric substitution in order for you to determine other functions. Okay, so from here, nakakuha kita value aton secant, tangent, so on and so forth. Okay, so for the next problem, this is just basically the same, except we're gonna be using with, it's gonna be using x is equal to 3 sine of theta. And since this utilizes theta, what you'll end up with this one is this one, cosecant theta squared plus sine of theta squared is equal to 1. You're going to be utilizing this one, and the process is just basically the same. That's how you use trigonometric substitution. Sige. Any other question? Eto na. Ito yung meet for today's lecture actually. We are, what's the time? It's 6:10. Okay, we're up to 7 man. We are to verify trigonometric identities. Eto na. Ito yung pinaka-favorite ko sa trigonometry. Kay parang there is no single answer. You can have multiple solutions pala. You can have multiple solutions depending on how you attack the problem. Okay? Parang sige, kung hinot mas maupay. Okay? So ito yung step, not necessarily step by step process, but this will help you on how you verify trigonometric identities. But ultimately it will be dependent. I mean, it will depend on how will you attack the problem. Parang ito guide lang ito sila. Parang tips on how you solve trigonometric identities. So first, ito. It says that you are to work with one side of the equation at a time. Baga, isa-isa lang. It is often better to work with the more complicated side first. Okay? So, mas mapay ko no. Mas madagmit ko no ang more complicated side. Kay, in my experience, usually, if you start with the more complicated side, di ba, you have two parts of your equation. You have the left side and the other side. So if you start at the more complicated side, ultimately it will be equal to this one. So that's how you're gonna prove that the equation is indeed equal. Okay? And ito, look for opportunities to factor an expression. Ito, that's what we did earlier in using 1 plus sine x multiplied by sine x minus 1. Ito, that's what he mean by this one. Look for opportunities to factor an expression. Add fraction, square the binomial, or create a monomial denominator. Yun niya. Create a monomial denominator. What we did earlier. Look for opportunities to use the fundamental identities. So, your cosine of x squared plus sine of x squared equal to 1. Note which function are in the final expression you want. Kita ako na mo target. What's your target? Sines and cosines pair up well. Ito nga, it's because of this one. As do secant and tangent, di ba? Secant and tangent, 1 plus tangent squared is equal to secant of x squared. Okay? And cosecant, cotangent. So we have also an identity for that. If the preceding guidelines do not help, then try converting all terms on sines and cosine. Okay? So yun, parang tips. May dapat pala ikalima. Always try something. Ito yung talaga eh. Ito talaga yun eh. Always try something. Even making an attempt that leads to a dead end can prove insight. Why? Kaya kung maaram ka na nga dead end ito nga method, ay napagutro ha. Di ba? Di ba na anong saring ni Einstein? Anong famous quote ni Einstein? Doing the same thing twice and expecting a different result is called foolishness. Yung saring ni Einstein. So, at least, kung maaram ka na nga dead end ito or sayop ba ito or dumped ito ya. So, ay napag-agi nga ito. Stupid ka na ito kung maagi ka ito nga ito. It will be stupid if you're gonna expect a different result from the same method that you used. Okay? Sige. Eto. For the first example, we are to verify this one if this is truly equal to sine squared. How are we going to do that one? How are we going to verify that this identity is indeed equal to this one? How are we going to do that? What have we learned so far? We learned how to factor, we learned how to add, we learned how to substitute. Okay, and also we learned to multiply something in order for us to create in order for us to use the basic trigonometric identities. So how do we verify if this is truly equal to this one? How are we going to do that? Ito na, what makes this hard is because you need to think. Mag-iisip ka talaga. And there is no one single solution. Okay, so Ayun na. How are we going to prove that this identity is indeed equal to sine theta squared? Are we going to do that one? So we can have this one. Secant of theta squared over secant of theta squared minus 1 over secant of theta squared. That's basically the same with this one, right? And this one, this will become 1. Diba? So you'll be left with 1 over secant theta squared. But what is secant theta squared equal to? That is what? 1 over cosine. And takay, denominator ya, mari-reciprocate na lot ya. So you'll have cosine theta squared. Okay, equal to sine of theta squared. But what is this one equal to? Diba? From our cosine theta squared plus sine of theta squared is equal to 1. Tama. If you try to transpose this one to the other side, you'll be left with sine of theta squared equal to 1 minus cosine theta squared. So this expression is basically equal to sine of theta squared. Sine of theta squared. So therefore, the left-hand side of the equation is indeed equal to the right-hand side of the equation. Butangan mo yan, check. That's how you prove identities. Okay? Do you have any questions? Okay? Butangan ito niyo yung check. Indeed equal. Okay? Sige, that's how you prove identities. For the next example, we are to verify that this one is equal to this one. How are we going to do that? Anong sharing tips? What does the tips say? What does the guideline say? Always start with the more complicated side. Which one is more complicated? The left-hand side or the right-hand side? Right-hand side. So we're gonna start at the right-hand side. So 2 secant of alpha squared is equal to 1. Okay. Let's add this 2. Let's directly add this 2. So I'll have 1 minus sine of alpha times 1 plus sine of alpha. Diba? Adding fraction. So if you have 1 over a plus 1 over b, okay, a and b, tapos b plus a. Diba? In your algebra. So similar to this one, 1 plus sine of alpha plus 1 minus sine of alpha. Sine of alpha, negative sine of alpha and positive sine of alpha cancels out. What will remain is 2 over your denominator. What is your denominator equal to? 1 minus sine of alpha squared. Sine alpha squared. But what is this equal to? Again, from this one. Okay. 1 minus sine. So, edi cosine. 2 secant of alpha squared. 2 over cosine of alpha squared. Diba? From this one. If you try to substitute, if you try to transfer this one to the other side, making 1 minus sine. So, edi cosine of alpha squared. And that is also equal to 2 over 1 times 1 over cosine of alpha squared. Diba? This one is equal to this one. If you try to do cross multiplication, the one cancels out basically. So you'll be left with the same thing. 2 over cosine of alpha. But what is cosine of alpha? What is 1 over cosine of alpha squared equal to? That is equal to what? Secant of alpha. So you'll be left with 2 times secant of alpha squared equal to 2 ngan secant of alpha. 2 times secant of alpha squared. Indeed, they are equal. Okay? Prove na ito. Nakuha. Imagine from this one to tikada. So what we did earlier is just the single side. Kumbaga, di ba, what we did kanina, we add trigonometric functions in fraction form. So So what we did kanina is just a prelude to this one. So we need those skills in order for us to verify trigonometric identities. It catchy din eh. Because not all of the problems, they are equal. Okay? You'll be stumped. Masaring ka ba? Marisya din eh kay masaring ka. Di ko man na-prove. Meaning, sa'yo pa da ini. Or, may problema ni mo solution. Asya waray mo ya ka-prove. Haay man dida. Mo itot marisyo. Ay, mag-iisip ka kung hain team sa'yo. Kumbaga, programming, magdidebug ka. Okay, next. Eto. Verify that this lot is indeed equal to the negative tangent of x squared. Again, where are we going to start? We start at where? The more complicated side. We start at the more complicated side. So, since medyo maraksot pagkiton kay halaba, unlike this one, sa lahiya kay trigonometric identities, we start with this one. Okay, so ito, tangent of x squared plus 1. Diba? We have your identity 1 plus tangent of x squared equal to secant of x squared. We can rewrite this one dayon. Easy. So, this will become secant of x squared. Nala. And this one, cosine of x squared minus 1. So, we have this identity, cosine of x squared plus sine of x squared is equal to 1. So, if you transpose this one to the other side of the equation, you'll have cosine of x squared minus 1. And transpose this one to the other side, you'll be left with negative sine of x squared. Nakuha. So, therefore, cosine of x squared minus 1 is indeed equal to this one. Minus sine of x squared. So, you just play with the trigonometric equations that you know. Then, okay na. Okay? Sige. And that is equal to negative tangent of x squared. Okay. What is the trigonometric identity for secant? That is 1 over trigonometric identity for secant. 1 over cosine x squared. 1 over cosine of x squared multiplied by negative sine of x squared equal to negative tangent of x squared. Okay, so if you try to multiply these two, it will become negative sine of x squared over cosine of x squared. Diba? And what is this equal to? This is basically equal to tangent, right? So you have negative tangent of x quantity squared equal to negative tangent of x squared. Negative tangent of x squared. This is indeed correct. Okay? Marisyo ba? So, for this one, we're given tangent of x plus cotangent of x is equal to secant of x cosecant of x. Ito. Which side are we going to start? Left or right? Left. Sige, tingnan kita left. Sige, tingnan kita left. What is tangent x equal to? What is the trigonometric identity for tangent? That is sine of x over cosine of x. Plus, what is cotangent? Cosine of x plus sine of x. Right? That is equal to secant of x times cosecant of x. Okay, if you try to add these two, you'll have cosine of x sine of x times sine of x squared plus cosine of x squared equal to secant x cosecant x. What is sine squared plus cosine squared? That is 1. Cosine of x sine of x. Secant of x cosecant of x. Okay? And this one, pwede mo bulagon. 1 over cosecant x times 1 over sine of x is just basically the same. Secant of x cosecant of x. What is 1 over cosine equal to? Secant of x, right? And what is 1 over sine equal to? Cosecant of x, right? They are indeed the same. That's how you prove. How about if you try to start at the right side? Sige na. Yun yung maganda. If you try to start from the right side of the equation, tangent of x plus cotangent of x. Okay. What is secant of x equal to? What? 1 over cosine of x times. What is cosecant of x equal to? 1 over sine of x. Yun. Di ba? From this one, 1 is equal to cosine of cosine x squared plus sine of x squared. So we can have this one, cosine of x squared plus sine of x squared over cosine of x times sine of x. Di ba? And we can, pwede tanan ni bulagon na nga dudu. So you can have cosine of x squared over, divide na lang adaan. Cosine of x squared divided by cosine of x times sine x. So you'll have cosine of x over sine of x plus sine of x squared divided by cosine of x times sine x. Cancel ito sa cosine. So you'll have sine of x squared, sine of x over cosine of x. Since this is cotangent plus tangent, so these are basically the same, tangent and cotangent. Okay ba? You can start anywhere you want. Marisyo ba? Again, as I've said earlier, there is no one single solution. Okay, depende mo. How do you do it? All right. So for the next problem, so we are given this equation, 1 over 1 minus cosine of x is equal to cosecant of x squared multiplied by 1 plus the cosine of x. So how are we going to verify this trigonometric equation? So remember what we did earlier with this similar denominator of a fraction. So if you remember, what we did was we tried to rationalize, we tried to multiply the fraction. We tried to multiply the fraction by something, and that something should lead us to our basic trigonometric identity, our sine x squared plus cosine of x squared, that is equal to 1. Okay, so we need to multiply this fraction by that something. So remember what we did. Okay, that is 1 over 1 minus the cosine of x. We try to multiply this one by 1 plus the cosine of x. 1 plus cosine of x. So that, okay, so I'll just write the right hand side of the equation. 1 plus cosine of x. So that after we multiply this one by 1 plus the cosine of x over 1 plus the cosine of x, okay, it will look something like this: 1 plus cosine of x all over 1 minus cosine of x squared. And what is this equal to? Okay, so again, remember in our basic Pythagorean identity, we have sine x squared plus cosine of x squared that is equal to 1. So if we try to put this one to the right hand side of the equation, we'll have sine of x squared is equal to 1 minus the cosine of x squared. Okay, so therefore the denominator now becomes a single sine x squared. Okay, so we have cosecant of x squared multiplied by 1 plus the cosine of x. Okay, since this will become a single sine of x squared, okay, we can now chop this fraction into 2. So we can have 1 over sine of x squared and the cosine of x over sine of x squared. Since the denominator is just now equal to sine of x squared, we can now factor out actually 1 over sine of x squared. So we can have 1 over sine of x squared multiplied by 1 plus the cosine of x. And what is 1 over sine of x squared equal to? This is basically equal to what? Cosecant of x squared. Okay, so I'll continue here. So therefore, if this is equal to cosecant of x squared, we have cosecant of x squared multiplied by 1 plus the cosine of x, that is equal to cosine of x squared multiplied by 1 plus the cosine of x, and therefore they are indeed equal. Okay, or that's how you verify this trigonometric equation. Okay, for the next problem, let's say we start at the right hand side of the equation. So we have secant of x plus the tangent of x, that is equal to cosine of x all over 1 minus the sine of x. So as you can see, again we now have another 1 minus sine of x. So what should we multiply? So I guess we can multiply 1 plus sine of x over 1 plus the sine of x. Why? Why should we multiply this one? In order for the denominator, okay, I'll try to write this one as though, meaning this is the same with the second line. Okay, so the denominator will be equal to 1 minus sine of x squared. And what is 1 minus sine of x squared equal to? It's basically equal to cosine of x squared. So the numerator now becomes the cosine of x plus the cosine of x sine of x. Okay, so I'll write do in here, meaning that's the same, all over the cosine of x squared. Okay, cosine of x plus the cosine of x sine of x. Okay, as you can notice, we have another cosine in here. They both have cosine, so we can factor that out. So cosine of x is equal multiplied by 1 plus the sine of x all over the cosine of x squared. Okay, we now have another cosine in the we now have a cosine on the numerator as well as the denominator. We can cancel one of the cosine, or if I try to write this one into two trigonometric identity, I can have cosine of x multiplied by the cosine of x. They are just basically the same. So therefore we can now cancel this one, and we'll be left with 1 plus the sine of x all over the cosine of x. Okay, again we now have a fraction. We can chop this one into two. We can have 1 plus 1 over cosine of x and the sine of x over cosine of x. Okay, that is equal to 1 over the cosine of x plus sine of x over the cosine of x. What is 1 over cosine of x equal to? That's basically equal to secant of x. And sine over cosine, that's basically equal to tangent of x. So therefore, they are indeed the same. Secant of x plus the tangent of x. Okay, they are indeed the same. Okay, so let's try this another. So let's try this another equation. So we're given cotangent of theta squared over 1 plus the cosecant of theta is equal to 1 minus sine of theta over sine of theta. Okay, normally, okay, from the our guidelines or our tips that we've discussed earlier, we try to focus on one side of the equation. Then from there, we try to prove that indeed these two identities are equal. Okay, but there are times that you need not necessarily focus on one side of the equation. You may have also to manipulate or to simplify the other side of the equation in order for you to find out really that they are the same. Okay, like for example, for this given example, so in this type of problem, so we need to manipulate both sides of the equation in order for them to prove that they are indeed equal. Okay, so again, we're given cotangent. So from our Pythagorean identity, we have the sine of x squared plus the cosine of x squared, that is equal to 1. If we try to divide both sides by sine of x. So this will become 1. This will become cotangent of x squared. And 1 over sine is cosecant of x squared. Okay, so cotangent is basically equal to what? Cotangent x squared or cotangent of theta squared is equal to cosecant of theta squared minus 1. So we try to write that down. Okay, cosecant of x squared minus 1 all over 1 plus the cosecant of, okay, cosecant of theta squared minus 1 all over 1 plus the cosecant of theta. Or we can write this 1 plus cosecant of theta as cosecant of theta plus 1. So I'll try to write this one separately. I'll try to simplify this one separately. Okay, so for this one, okay, what can we do? Anong pwede natin gawin? We can factor out this one. We can factor the numerator. So for the numerator, we can have cosecant of theta plus 1 and the cosecant of theta minus 1. So if you try to multiply those two binomial, you get the numerator all over the cosecant of theta plus 1. So basically, this one cancels out. You'll be left with the cosecant of theta minus 1. Okay? Okay, so how about if we try to manipulate naman the other side of the equation? So for the right hand side of the equation, if I try to chop this fraction into 2, I can have 1 over the sine of theta. And what is 1 over sine of theta equal to? That is basically equal to cosecant of theta. Okay, and minus 1. So therefore, cotangent of theta squared over 1 plus the cosecant of theta is equal to 1 minus sine of theta over the sine of theta, which is also equal to cosecant of theta minus 1. Cosecant of theta minus 1. They are indeed equal. Okay, so again, some of the problems may require you to manipulate both sides of the equation, not just one side of the equation as suggested in the guidelines. Again, the guidelines are just the tips. They are not necessarily the process on how will you solve a particular problem. Gabay lamang sila. Yon. Sige. And for the last problem, so we are given two examples from calculus. Okay, we're not finding the differential in here. Okay, we're just using the idea of trigonometry. Okay, which is a necessity in your calculus. So let's start with letter A. So for letter A, it says there that the tangent of x raised to the fourth power is equal to tangent of x squared secant of x squared minus the tangent of x squared. Okay, so I'll write this one as though, meaning it's the same. I can factor out tangent of x in here. Tangent of x squared multiplied by the secant of x squared minus 1. Eto na naman. So we have secant squared minus 1. Okay, from our trigonometric identity, if it, Pythagorean identity, if we try to divide this one by cosine, I can have tangent of x squared plus 1, that is equal to 1 over cosine, that is secant of x squared. So if I try to transfer the positive 1 into the right side of the hand side of the equation, I have the tangent of x squared is equal to the secant of x squared minus 1. So basically, this lot is equal to what? Tangent of x squared. So therefore, I have the tangent of x squared multiplied by the tangent of x squared. Okay, or if I try to multiply those two, I will have ultimately tangent of x raised to the fourth power, which is actually equal to this one. They are indeed equal. For letter B naman, okay, the idea is basically the similar. For letter B, the idea is basically the same. So we have the cosecant of x raised to the fourth power multiplied by the cotangent of x. That is equal to the cosecant of x squared multiplied by the cotangent of x plus the cotangent of x raised to the third power. Okay, I'll write do for simplicity. So again, I can factor out cotangent in here. So I have cosecant of x squared multiplied by cotangent of x multiplied by 1 plus the cotangent of x raised to the second power. Again, from my trigonometric identities, what is 1 plus cotangent of x squared equal to? That is the cosecant of x squared. Okay, so I have cosecant of x squared multiplied by the cotangent of x multiplied by the cosecant of x squared. They are basically the same. So, same base, you add the numerator. Same base, you add the exponent. So, I have, therefore, cosecant of x raised to the fourth power multiplied by the cotangent of x. And that is equal to the left-hand side of the equation. Okay? Question? Okay. Assignment. So, we have page 102 and 103. So that ends my presentation on basic verifying of trigonometric identities, as well as sharing the ideas of algebra which are used or useful in your trigonometry. Okay, so thank you for listening to the lecture, thank you for bearing with the lecture, and see you again in the next video. Salamat and paalam.